Hello everyone, welcome back to 3 Deviations. So in the last video of single variable calculus, we introduced Newton's method, which allowed us to find the zeros of some polynomial functions. Well, we're going to use this for a little bit of trigonometry today, and we're going to work out how we can find an intersection between two graphs, or the x-coordinate of an intersection between two graphs. So, as always, I would recommend, if you haven't watched the video introducing Newton's method, maybe it would be nice to review that, just so that you know what is to come. So, let's talk about our example. So, today's example says that we are going to determine the root of cosine of x equals x, correct to 6 decimals. So you can kind of graph this out, what this is going to look like, although it probably won't be extremely helpful, but it's just nice to know what something looks like sometimes. So we can draw in our graph x here. It's just going to be a line with a slope of 1. It's going to go off to infinity and negative infinity. And then I'm just going to deal with one little part of cosine. So we're going to have cosine here. And it's going to be like that a little bit. And then we're trying to find that there. We're trying to find the x point there. All right, well, first we can make our functions like we did last time, the ones that we're going to need to differentiate, right? So we are going to determine that the function that we're looking at is that f of x is going to be cosine of x minus x. And then our f prime is going to be just some simple differentiation. It's going to be negative sine of x minus 1. All right, and now we can kind of make our formula to find x of n plus 1, right? So x of n plus 1 is going to be x of n plus cosine of x of n minus x of n over sine of x of n plus 1. So there is the formula that we are going to use to find our next approximation. Our first approximation we are going to choose to be 1, and after this we are going to plug this into our formula and it's going to spit out some values. So I'll give you a little bit of time, or pause the video to spit this through your calculator, but to find it correct to 6 decimals, we're going to need to go to about 4 or 5 approximations using that formula. And while you're doing this, please be sure to set your calculator to radian mode, and that will give you the correct answer here. So if we keep plugging in through the formula, we are going to start converging as we get closer and closer, and we can actually see that we're converging so much that our calculator is going to spit up very similar identical x of 4 and x of 5s. And that's how we know that we're convergent. And it turns out that this is actually accurate to all of the decimal places that we have here, but of course our answer would go on and on if we kept taking x sub n roots. So that is really it for determining how we can use Newton's method to find some of our zeros. And of course, again, this was an instance where it worked really nice for trigonometric functions. And it shows that approximations, while a little bit messy with all of these decimal points, can work pretty well. I mean, we're getting converging answers here. And if you were in a physics or engineering class, in most cases, these approximations would suffice. Normally in physics and engineering, you use a lot of approximations, probably even more approximations than we've done. But this would come in handy a lot in a course of that nature. So in the next video, we are going to be talking about more Newton's method to determine the square root of 2. So we're going to use it to define some algebraically constructible numbers. So that is to come, and we will see you then. Have a great time studying some nice single variable calculus.